Hey you guys, it's Andrew here, and today I'm going to be doing the second installment of the calculus tutorial series. Last time I talked about instantaneous rate of change. Today I'm going to be talking about the comparison between instantaneous rate of change and average rate of change. So, if you remember taking algebra, you probably remember this formula: delta y divided by delta x is equal to y2 y2 minus y1 divided by divided by x2 minus x1. Okay, and you'll probably know it in its other form, which is f of b, okay, minus f of a and b minus a. Okay, so you'll probably get this, and the thing about this is that this is just an average. It's not precisely accurate, depending on what you're going to be dealing with at all. So it's fine for certain things where the accuracy is not that important, but in some things the accuracy is important. And what I mean by that is this. Okay, let's say you have a graph, and let's go ahead and draw up a curve. Okay, this is a parabola. Okay, this is the formula, the function f of x equals to x squared. X is equal to 3. Let's say it's equal to 3. So let's say, for instance, let's say 3 is right here. Okay, and that would make it roughly somewhere around here. Okay, just okay. So that would equal that the function is 9, because pretty much 3 squared is 9. Okay, now let's say that you want to find the rate of change, the average rate of change. If you go by the average rate of change, then that pretty much means this. Okay, let's say for example that x x2 is equal to 3. That's your same deal here. Okay, 3. And x1 is equal to 0. Okay, now considering your secondary point is here and your primary point is here. Okay, let me just go ahead and write it here. Okay, you're pretty much getting the rate of change, the average rate of change, which pretty much means that you jump across directly from here to here, but you're not considering the overall curve, which means that there's a lot of errors if you're considering average rate of change. Now, Let's go ahead and do work out the operation of this. Okay, so we already have x of 2. Okay, we already have x of 2. And x of 2 is 3. Okay, minus your initial, which is x of 1 is 0. Now you go. We still need to find um, f of x of 2 and f of x of 1. So we for f of x of 2 we plug in um, x of 2. Okay, 3 squared we already know is 9. Okay, minus f of x of 1 we plug in 0. We already know that's 0 squared is 0. Okay, and that leaves this. Let me go ahead and draw it over here. um, 9 divided by 3, okay, which is equal to, you simplify this, is gives you 3 over 1, which is equals to 3. Okay, it equals to 3. So your slope, your average rate of change is 3 in this case. Now let's keep in mind let's keep in mind that this is the average rate of change. Keep in mind it's 3. Let me just erase this and I'm gonna write it down. Okay, now average rate of change, AVG rate, okay, rate is equal to 3. Now let's go ahead and bring back the instantaneous rate of change formula. So first let me rewrite the function, which is f of x is equal to x squared, and x is equal to 3. Okay, I don't know why this thing does this. I always have trouble writing with this thing, but it's the best thing I can get it on, or I'm probably not using it right. Anyway, so if y'all remember the original formula correctly, is is f of x, and keep in mind this is instantaneous rate of change, not average rate of change. Okay, f of x equals limit h approaches to 0. Okay, f of x plus h minus f of x. Okay, divided by h. Okay, so now that we got our formula here, let's go ahead and plug in the rates. So so pretty much our x is 3 and our function is x squared. Okay, so what we do is this. Let's get okay, x plus h squared minus, hold on, minus x squared, okay, divided by h. So what we do now is we go ahead and plug in our 3 value. Okay, so next we plug in 3 plus h squared, okay, minus 3 squared divided by h. Alright, now that we got this, let me go ahead and simplify this now. Okay, so let me just get this over here and um, erase this extra stuff. Now that you got all this, okay. Okay, there. And put this back. This is a 3. Alright, now what we do is just we go ahead and simplify it. So write it down, and we have 9 plus 2 3h plus h square minus 3 squared divided by h. Alright, now next what we do is that we go ahead and simplify it even further. So go ahead and get this. And we write down 9 plus 2 times 3, which is 6h plus h squared minus 3 squared is 9. Okay, and of course h. Now notice something here, 9 and then minus 9, so we can go ahead and cancel these out, and what we have left here is this, which is 6h plus h squared divided by h. Okay, and another way you can write this is like this. Okay, so h 6 plus h and h, and we go ahead and cancel these out. Okay, now what we have here is we pretty much have this result here, which is 6 plus h. And what is h? H is remember our formula that we wrote, where remember limit of h and limit of h, okay, hold on, 8, okay, H approaches to 0, okay, it approaches to 0. So that means that this right here is 0, okay, this is 0, okay, so which means that our result here is 6. That means our instantaneous rate of change is 6. So if you compare this 6 to your 3, that's twice the difference. That's 2 times your rate of change than your average rate of change. So anyway, this concludes our session, and thank you guys for watching. Please like and subscribe, and I'll catch you guys next time. Bye.